On old Christmas tree lights, when one light went out, the whole string went out at the same time. So we want to know, how are these old Christmas lights attached? Are they attached together series or parallel? In other words, are all the bulbs in series with each other, or are all the bulbs in parallel with each other? Well, let's look at the two configurations that I've drawn out before. Now each one shows 3 light bulbs. In the first picture, I show 3 light bulbs connected together in series. Now in series, we know that the current leaves the battery and first must flow through the first light bulb, then the second, then the third, and make its way back to the battery. Now what happens if one of them burns out? Well, a light bulb is just a really thin filament of wire. Certainly the old ones were just a thin filament of wire. So if they burn out, it's like you can imagine there's a gap all of a sudden. And we know that current can't flow through a gap, an open circuit. So the current simply stops flowing because this is series. There's no alternative for the current to flow, so it simply stops. That means all the bulbs go off together if one burns out in series. And it's always a bit of a task trying to figure out which bulb burned out back in the old days. You had to take a fresh bulb and literally feed it through every single socket until the whole thing went back on. It was a bit of a pain. Now let's make sure we're right. Let's look at the parallel situation. So parallel current comes out of the battery, but in parallel it has a choice. Part of it can go through the first section, bulb A. The second part can continue on and then hit this junction where part of it goes through bulb B and part of it goes through bulb C. And hopefully you can see from the picture, if one of these bulbs burn out, let's just pick the middle one, the current will no longer flow through that bulb, but that doesn't stop the current from flowing through the outer bulb or this first one that we drew in the beginning. So the overall circuit will draw less current because there's one bulb less, I guess, in the circuit, but the other light bulbs will remain lit. So the old string of lights, if one light goes out and all the others go out simultaneously, we would say that's in series. Now the reality is, just as a little point of interest, the newer circuits, they have a light bulb, a traditional, it's more of an LED now to use less current. They still use this series configuration, but what they've added is a little shunt resistor. And the little shunt is basically just a little piece of oxidized metal that they loop around the legs of the light bulb. So what happens is when the light bulb burns out, so the top of it literally melts, this oxidized metal, now oxidation creates like this really, really thin insulative coating. So before the light burns out, that's just like a little piece of, you can imagine as a little piece of rubber around the legs. Current can't flow through it. But when the light burns out, and you'll learn this later, the resistance goes to an infinite value. It's a huge resistance all of a sudden, which makes sense because current can't flow through it. And when the resistance gets big, the voltage across that light bulb, that burned out light bulb, also gets big. In other words, this burned out light bulb will get the full 110 volts from your house across it momentarily. So when you've got all that voltage across it, it creates heat. And this little shunt resistor, we call it, it's enough heat to melt off that little bit of oxidation. And then once it melts off, it's no longer a shunt resistor. It's just another wire, and the current continues to flow through the rest of the light bulbs. So what happens is, if a light bulb burns out on the modern ones, the string goes off for a second, the shunt resistor gets hot, burns off the oxidation, and it shorts through the bulb, and all the rest of the light bulbs end up going back on again.